Welcome to More Learn, More Teach, where I attempt to simplify the complex. Today we want to talk about inequalities. So let's start with an example. So here I have two jars of water. Okay, I have a reference line. So anything that is above the reference line we're going to say is a positive value. Anything below the reference line is we're going to call a negative value. Right? So relative to this reference point, this is positive, this is negative. I have an inequality. The bigger side of the inequality is the bigger quantity. So this is a greater than. This quantity is greater than this quantity. So I have this relationship. Now, if I have this relationship and I were to add a constant quantity of water to both sides, I would not change the relationship. So we can see that. If I add some quantity C to this side, and I add the same quantity C to the other side, I have not changed the inequality. If I were to write this as algebra, that would be A is greater than B, we started with. A plus C is still greater than B plus C. That's the way we represent what we've done here. I can subtract some quantity D. Do this to both sides. Let's say that we're still above zero. We'll see in a minute, it won't make a difference. Then I'm going to have A minus D is still greater than B minus D. Multiplication is a little more tricky. So in general, what I do to one side, I do to the other side, I don't change the relationship. That's true unless I multiply by a negative number. Same thing with division. If I divide by a negative number, that's going to change my inequality. Okay, so if I multiply, let's say I just multiply this by 10, that's the same thing as multiplying this by 10. So what I would have here, if I had $100 in my bank account, or I had $100 of debt, multiply them by 10, I'm going to end up with $1,000, which is still greater than negative $1,000. If I multiply this by negative 10, though, now I have negative 1,000 and positive 1,000. This is no longer true. I have now changed my inequality. I've gone from a greater than to now a less than. So when I multiply both sides by a negative number, I must flip the inequality. The same is true for division. If I divide both sides by a negative quantity, then I've got to flip this inequality. So here's an example. Let's say we have 4x minus 5 is less than 5x minus 4. And what we're trying to solve is a relationship of what values of x are possible in order for this to be true. So what we can do is we can get the x's on both sides. That would be helpful for us. So I could either subtract 4x from both sides or subtract 5x from both sides. I'm going to choose to subtract 4x from both sides. So if I subtract 4x, this will cancel. Negative 5 is still less than 5x minus 4 minus 4x. Negative 5 is less than 1x minus 4. I can now add 4 to both sides. So if I were to add 4, I have not changed the relationship. And I have 4 minus 5 is -1, is still less than x. So all values of x must be greater than -1. So we'll write this another way. All values of x must be greater than -1. So any value greater than -1 will solve this equation. So let's see if that's true. Let's say that x is equal to -0.5. Let's see if this is still true. So 4 times -0.5 minus 5, we're saying that that is less than 5 times -0.5 minus 4. -2 minus 5 less than -2.5 minus 4, or -7 less than -6.5. That is true. Next, we want to talk about absolute value. So the absolute value is the magnitude of the quantity, right? So let's say that I have an example where I have two cars that are driving towards a collision point. Let's say that we have set this collision point as 0. So relative to this point, this car has positive speed as it's going this way on our axis. This car has negative speed as it's going this way on the axis. Let's say that they were equal. Well, if I added them together, then it would be 0. But we know that if I have a car moving at another car, there's going to be a collision that's going to cause some damage, right? What that depends on is the absolute value of this speed, the magnitude of this speed, and the magnitude of this speed. They will give us an indication of how much of an impact damage there will be. So absolute value. So how do I find the absolute value? I just drop the sign. I don't care about the direction. I only care about the magnitude. That's that absolute value. So absolute value is magnitude. So let's put these two concepts together and solve for absolute value inequality. All right, so the symbol for absolute value is a straight line. So now I have an example where I have the absolute value of -3x plus 5, that magnitude, that absolute value, is greater than 10. In order to figure out what the relationship x must be, we got to solve two problems because we don't know the direction, right? All we know is the magnitude of this value is greater than 10. So I've got to solve for two problems. One case where this quantity is a positive and one where this quantity is negative because it has the other direction. So I have -3x plus 5 is greater than 10, and if I take the negative of that, I have greater than 10. So I have to solve such that x can have these two conditions. It's got to be able to fit into this or this in order to make this true. It's an or statement because this is an absolute value. So if this is true or this is true, then this relationship is true. All right, so let's walk through the solution to this problem. So as I said, we are solving two problems. We're solving -3x plus 5 is greater than 10, and we're taking the negative of this quantity is greater than 10. So we'll do this one first. So let's subtract 5 from both sides. I have not changed the inequality. That removes this 5, which gives me -3x is greater than 5. For the next step, I'm going to divide both sides by -3, or multiply both sides by -1/3. So now I'm going to multiply both sides by -1/3, but when I multiply by a negative or divide by a negative, I have to change the inequality. So the inequality will flip on us. Okay, so when I do this, I end up with x must be less than -5/3. Okay, so that's one set. If we go to the other side, Again, I had negative 3x plus 5, negative of this, so this is the other direction. That must be greater than 10. Multiplying the negative 1 through, I get 3x minus 5 is greater than 10. Add 5 to both sides. I do not change the inequality. And I have 3x is greater than 15. So now I'm going to divide both sides by 3 or multiply both sides by 1/3. I'm multiplying by a positive number, so I do not change the inequality. I only change the inequality when I have a negative number that I'm multiplying through. So I end up with x greater than 5. So again, it's an absolute value. So this works whether or not it's positive or negative. Therefore, it's an or statement. So x must be either less than negative 5/3 or it must be greater than positive 5. Thank you for watching my video. Please like and subscribe. If you have any questions that I can help you out with, I'd be happy to try and answer your questions. Send me an email at morelearnmoreteach@gmail.com.